let's compute variance. I'm going to tell you up front, computing variance by hand can be a little tedious. So if you can use technology, it's easier, but let's understand what we're dealing with and how to do this. So first, variance is a measure of, it measures the spread of data, right? So it describes the variation in a data set. We often don't talk about variance, we use standard deviation, but they are related. So variance is kind of step one. Now, one thing I want to point out is that you have to make sure you understand whether you're dealing with a population or a sample because it changes the formula, okay? So let me just throw the formula at you. So basically, the formula for variance, which is sigma squared, this is for population, is the sum of x minus mu squared all over n. And you might be saying, I'm sorry, what does that mean? Well, we're going to get there. And if you have a sample, we call that s squared. So these represent variance, right? And the s just shows that the sample, where sigma is the population. And then we have the summation of x minus mu squared all over n minus 1. So really the only difference between a population and a sample is dividing by the sample size, or the sample size minus 1. So let's go through and talk about what all of this means, okay? We're going to find the population variance for this data set. Now we have 6 numbers, and I find that creating a table to stay organized is the easiest. So what I'm going to do is I'm going to say, okay, x means my data values. So I have 4, 8, 9, 10, 14, and 18. Start there. Now we know that our formula, this is a population variance, so sigma squared equals the summation of x minus mu squared all over n. Now, mu is the mean, so that means I need to find that first. So step 1 is find the mean. If I add these numbers together, 4, 8, 9, 10, 14, and 18, I get 63. And if I divide 63 by 6, I get 10.5. So my first step, finding the mean. Check. Step 2 is we need to find the deviation, which is x minus the mean. You'll notice that's in the numerator of our formula. So I'm going to make my next column in my table to be x minus mu. So I'm going to take every x value and subtract 10.5. So 4 minus 10.5 is negative 6.5. 8 minus 10.5 is negative 2.5. 9 minus 10.5 is negative 1.5. 10 gives me a negative 0.5. 14 gives me a 3.5. And 18 gives me 7.5. Now, if you add the deviation column, so if we would add this together, it should always equal 0. Okay, and it does. So we're good there. All right, so that's step 2. Find this column. Now you'll notice in our formula, the deviation, x minus mu, is squared. So step 3 is, let's square it. So I'm going to make my next column x minus mu squared. So I'm going to take that difference, that middle one, x, the like negative 6.5, and I'm going to square it. So I'm going to get 42.25, and then I'm going to get 6.25. Negative 1.5 squared is 2.25, 0.25, 12.25, and 7.5 squared is 56.25. Now you'll notice these are all positive, because when we square something, we take it times itself. 2 negatives is a positive, 2 positives is a positive. All right, we're up to step 4. So now that I have the x minus mu squared, now I need to find the summation. So we are going to add the x minus mu squared column. Okay, so I add this up. So I sum it up, that's the summation number there, and I get 119.5. So we now have the numerator of our formula. Well, what is n? N is our sample size. So in this case, we have 6 values. So understand your sample size, and then 6, plug it into your formula. So I know that this 119.5 is my numerator. So 119.5 divided by n, which is 6, running out of room, and rounded to the nearest hundredth, I get 19.92. So sigma squared is 19.92. So you can see if you create the table, it gives you a nice organized way to do this. Okay, let's do one more, but we'll do it as a sample. Okay, so remember the sample is s squared equals the summation of x minus mu squared over n minus 1. So here we're dealing with 5 numbers. So I have 12, 14, 18, 20, and 21. So again, we got to find the mean. So the mean, I add these together, and I get 85. I divide by 5, and my mean is 17. So now I can do the x minus mu column. And sometimes I will do x minus mu and x minus mu squared at the same time. Because for the first one, 12 minus 17 is negative 5. And negative 5 squared is 25. So I can kind of do 2 steps at once. And then 14 minus 17 is negative 3, and negative 3 squared is 9. So by doing it that way, it just makes it a little bit easier. Okay, so we'll finish this out, and there we go. All right, so now I've done kind of steps 2 and 3 at the same time. So I did the x minus mu squared. Now I need to sum them up, right? So the sum of x minus mu squared, when I add that column, I get 60. And we have to think about our sample size. So our sample size here is 5. So when I plug this into the formula, I'm going to get 60 over 5 minus 1. And 5 minus 1 is indeed 4. So my s squared is 15. So hopefully that makes sense on how we're going through the variance, and hope you enjoyed it.